All right, today we're going to talk about function inverses. Let's get into it. All right. So first of all, how do we know if a function has an inverse? Okay. Function has an inverse. It must be 1-to-1, which means it passes both the vertical and the horizontal line test. If it passes a vertical line test, it's a function. If it passes the horizontal line test, it has an inverse. Okay. So let's see. Let's look at our first example. We're passing the vertical line test. It does not cross the graph at more than 1 point. And then we do the horizontal line test. It passes the horizontal line test, meaning if I draw any horizontal line in the graph, it only passes through the graph at 1 point. So let's go. Vertical line test, check. Horizontal line test, check. Okay. Has a function. It's a function and has an inverse. But this next one, vertical line test. Well, it fails. It's not a function. Horizontal line test, not needed. It must be 1-to-1. Because since it's not a function, we're not going to do or bother with the horizontal line test. So go vertical line test. This one passes, it's a function. It's an absolute value function. Let's try the horizontal line test. You can already see it fails. So does not have an inverse. Now, what we can do with some functions is we can limit their domain. So let's take something like this. And let's say I draw a parabola, right? Well, if I was going to do the vertical line test, it's a function, okay? And then the horizontal line test, it fails. But if I restricted the domain, I said, well, let's only look at this function for x greater than or equal to 0. So now I'm erasing this over here. And now, I'll pretend I erased it, only started here. It passes the horizontal line test and we can find its inverse. So let's review the steps. We're going to use our example over here to do these steps. So I'm going to write in red. It's my favorite color. Step 1, rewrite this function using y instead of f of x. So I have y equals 3x minus 4. So step 1, we're done. Step 2, switch the x and the y. Well, I'm going to rewrite it. Now I have x equals 3y minus 4. I just swap places, okay? X is now over here, y is now over here. Next, solve for y. Well, let's not check it yet. Solve for y. So, add 4 to both sides. X plus 4 equals 3y. Divide both sides by 3. And I get 1/3 x plus 4/3 equals y. Solved for y. Now replace y with f to the inverse of 1. Right? F to the negative 1 just means the inverse of f of x. So now I have 1 f negative to the negative 1 of x. We're not raising it to the power. This is the inverse of x. There you go. Check the domain. What does that mean? What does it mean to check the domain? Well, it's asking, are there any values of x that violate, that just give me something that is not a real number? And no, we're good, right? Nothing turns a denominator into a 0. I don't have a negative under the exponent, so we're good. Okay. And then what's the domain and range of this guy here? Well, the domain is, that's negative infinity to positive infinity is good, and the range is going to be the same. Okay, it's also true up here. The domain is negative infinity to positive infinity, and the range is also negative infinity to positive infinity. Okay. So there'll be times where we have to determine if two functions are inverses of each other. So if they are, in order to test it, we're going to take the composition of each pair. So f of g of x, if that equals g of f of x, and both of those things equal x, then they are inverses of each other. So I'm going to write, this will be my red function. and this will be my blue function. So let's write f of g of x. So we have f of g of x is 2/3. That's part of f of x. X, but now that's g of x. Okay, so let's work through this. We'll distribute. This is x minus 6 plus 6. That equals x. So far, so good. Now we have to compose g of f of x. Does this also equal x? Let's find out. So now I rewrote. I have g, which is 3/2 times x, but now the x is actually f of x, so it's written in red here so you can see, and then subtract 9. We go back to part of the g function. So let's distribute. 3/2 times 2/3 is just 1, so I have x plus 3 times 6 is 18 divided by 2 is 9 minus 9. This equals x. Yes, they are inverses of each other. Yay. Now let's try the next one, and we'll do the same thing. We'll color code our functions so we can see when and where they're being plugged in. So you notice we put a domain restriction here because we have a radical and we also have an x squared. So let's write them out. All right. So I just put the parentheses in black, but the 2 is red because that is part of the f of x function. So I have this whole thing. Used to be x, is now g of x. That's why it's in blue. So I've substituted x for g of x. I squared it, and then I've added 5. Let's work through it now. This is really radical x minus 5 times radical x minus 5 plus 5. This is x minus 10 radical x plus 25 plus 5. This equals x minus 10 radical, where's my eraser? There you go. Minus 10 radical x plus 30. This does not equal x, okay? So we're actually going to stop here because if this doesn't equal x, it doesn't matter if the other one does. They're not inverses of each other because they must equal each other, and both of them must equal x. So not inverses. Okay. That's all we have for now. If you have any questions, you know how to get a hold of me or reach out. Take care.